all this time, any vector that I picked had direction. Do you agree? We can write through vectors using arrows. That is some point 1,3. That is the origin. If I want to write it in vector notation, how would I write it? Just one. You would write it as I vector plus 3j vector. Correct. So if I simply wrote it as I vector plus 3j vector, you are specifying a vector, but you're not giving an exact direction. By direction, I mean an exact amount on which way it's going. Good. What do we use to determine which way something is going relative to the x? What do we use to represent the angle relative to the initial side or the reference axis, no matter what that is? So, if I find the angle, then I would know the direction. Good. I need this. Pay close attention. I'm going to connect things. Now, what do I know about a point in a rectangular system? If I have a coordinate x and a coordinate y, and let's just say I'm looking at the unit cell. Good. What is the x coordinate? This you should know by now. In terms of theta. Have a unit circle, point on the unit circle. I want to know the x coordinate in terms of theta.
You're saying like our cos theta?
Our cosine. What? Is it cosine or is it half cosine?
The like the letter R. R and
Oh,
cosine.
okay. I'm talking about a unit exactly. So I'm getting that. Do we remember this? X is cosine theta and y is sine theta. Yes, no, maybe. Okay. And Jack mentioned, okay, we put the letter R in the front. Correct? Well, what does R correspond to, Jack?
The hypotenuse.
Oh, we'll get to that in a bit, but in terms of unit circle and circles,
Like the polar coordinate, so the x. Or, I don't think I understand what you're asking.
I mean, in terms of the circle, what is R? The drawing circle.
Radius.
Radius, okay. So R is the radius. If I draw a unit circle, the x coordinate is cosine theta, y coordinate is sine theta. But if I had a different radius, it would simply be R cosine theta or sine theta. With me so far. Okay. Now, you used a very specific word, Jake, when you mentioned R. Instead of radius, you said something else.
Polar coordinate system.
Before that.
I said a lot of words.
No, but I know. I'm trying to go back and think all the words you mentioned.
The x and y being r comma theta.
Okay,
And
that's the radius, correct? Yes. Now, don't want to mess up that picture, okay, that picture. Polygon, regardless. Let's say the radius is 2. No. And I pick a point over there. Yes. And what is the value of that?
Square plus y squared.
This would be just x squared plus
Or
y squared,
radical.
or square root of x.
Radical x squared.
This value would be square root of x squared plus y squared. With me? Well, why is that possible? Because in terms of theta, x is 2 cosine theta, y 2 sine theta. With me? So R simply is the radius, and how do we find the radius? Square root of x squared plus y squared. Good. Okay. In terms of vectors, that is the vector V. It has an x component, 1, a y component, 3, but it doesn't have duration. Good. Now I want to represent it in a way so that it has duration. In other words, theta. I need to find what theta is. Long time ago, I mentioned that anytime we talk about theta, we use one of the two functions. What is that function? If you spend a lot of time in the sun, tangent, right? So theta is simply tangent inverse of y over x. Correct. In this case, instead of a comma b that we talked about, a limitation for vector, why not call it as x and y? Same thing, right? Just different letter. A is x and b is y. Okay, so this would be xi vector, yj vector, and that is b. Good. So what you see up there doesn't have a direction, and means not the direction. Tangent inverse, anytime when we find an angle using x and y, what did we do? We did tangent inverse of something. What goes inside the parentheses? In other words, true. I could also say 1 over 3. Or root 3 squared. But in terms of x and y. In terms of x, y, not as numbers, the letter x and the letter y. Y over x. That going up. Yes. Okay. I have 3. I have 1. Whatever answer that I find, I want it in degrees. So let's go ahead and put your calculator in degrees mode. Sure, you can use radians also, but degrees would be easier to understand. tangent inverse of 3. What do we get?
72,
How much?
72-ish.
72-ish. I'll approximate it and call it 72 sequence. So I found theta to be 72 degrees. All I need is to find R. Yes? If I find R, then I will have the x component and the y component, both with magnitude. I've given you the hint already, and direction, which is this. Good. How do we find R in terms of x, y? The answer is there. Great. Looks like you know the answer. Very good. So R is simply the square root of x squared plus y squared. Right over there. Yes. Point x comma y. I connected that to r cosine theta, r sine theta. Now I'm rewriting it in terms of the vector v. Now, instead of calling it r is by all means the square root of x squared plus y squared. Good. If you look at that vector, and if you're finding the square root of x squared plus y squared, what are you finding? The magnitude. So whatever we talked about a long time ago, as in unit circle, all that, in vector language, it is simply the magnitude of the vector. Good. So, what is the magnitude of that vector? 10, square root of 10. Good. Now I know the angle. I know the magnitude. And I mentioned that in or when dealing with vectors, given that R and the magnitude of the vector one and the same. Yes. The vector v. If I want to bring in both direction as well as magnitude, how should I write the x component? Only magnitude, x was 1, y was 3. Yes. Now I want magnitude as well as direction. The answer is better. How would you write x? Louder, Jake, can't hear you. Radical 10 cosine into theta. What is the value of theta?
That's 72-ish.
72. I. Yes. Plus. The next one. Radical 10 sine is 72. J vector. Things get complicated as you go to higher dimensions. I can rewrite that as square root of 10, which is in common, times cosine 72 degrees, I vector, plus sine 72 degrees, j vector. Good. So that and that are one and the same. However, one gives more information than the other. That gives you both direction and magnitude. This one simply gives you magnitude. How do I know that they are referring to the same thing? Pick up your calculator, multiply square root of 10 by cosine 72, and tell me what you get. Make sure it is in degrees mode.
Like 0.99.
Jack says it's 0.99999. Okay. What about square root of 10 times sine 32? 2.99. The 3.007. Okay, one market things value slightly off. It was 1 and 3. Here I have 0.999 and 3.000. They're off because we rounded slightly. Degrees. As a name. Starts with the letter A, ends with E. That's L and okay. 72 degrees. We approximated that, which would mean those what's the balance. Now you see what I mean when I say that's just a vector with only magnitude. This one specifies magnitude as well as convention. But in some cases, we need that. In other cases, that's good enough. So physics, for instance, we want this. Statistics, I don't care about the number, all I need. Now there are instances where it will come into play, but I'm not going to get into that. Why would this matter in physics? Think of, how a wind is blowing and you've got this hanging bridge and it's swaying back and forth. Yes. So you've got wind coming in this direction. So the bridge is resisting. So there is a force this way, there is a force that way, and then there's a force down. What is the force that's pulling the bridge down? Gravity. So you've got all sorts of directions and forces. So in a case like that, we need to represent vectors of both magnitude and direction. But by all means, they are one and the same. Good. Okay. Good place to start. Do one more example and an application before we move on to specific. We do